In this video, we're going to literally measure the acceleration due to gravity's value. So for that, we are going to make use of this particular setup. This is your circuit diagram and this is the actual photo. So the key things over here is that we need to know, first one being your electromagnet, second one being your load, third, actually first B. So electromagnet along with the switch is to be understood, and the third one is your switch, and fourth one is your time module. Okay, so let's look into them one by one. First is an electromagnet. What is it? What is it made up of? Well, you have a metallic rod in the middle wrapped with copper wire, insulated copper wire, something like that. Okay guys, so what is that it does? Well, let me explain with this. Switch A, which controls the current flowing in this copper wire, right? When we switch it on, what happens to the electromagnet is something that we need to know. So when the switch A is on, the current flows and the electromagnet becomes a magnet. When switch A is off, the electromagnet becomes it demagnetizes. It demagnetizes. What does that mean? It becomes a normal metal. Okay. Next thing is we need to understand about the load. So load is not shown in this photo. It is a metallic. It has a metallic tip with some mass over here, making it a bit heavy. Okay. You have seen that in one of the videos. I'm making use of the same thing. So I have a metallic tip with a mass over here. So I have it over there, right? How is it stuck over there? Why is it not seen over here? You'll understand in time. Switch L is nothing but something which is directly below all of this setup. That's your switch L. So that's our switch L. Switch A and the time module is not seen. What does the time module do? Well, let me explain it this way. When we switch off switch A, right? When we switch off the switch A, this becomes demagnetized and allowing the load to fall towards the switch L. Okay guys, so when it falls onto this, what happens? Obviously it will switch on, it will switch on. Literally, it's a switch which is just hanging over there in the air. How is that I made it? Well, that is something that you guys can be imaginative. You can think of the ways to do that. It will switch, it will fall on the switch and this circuit will get switched on. This time module will measure, it measures the time switch A is switched off and switch L is switched on. Okay, so this is the entire picture. Got it? So the time taken for the load to come from point A to point B is what it does. Time measuring module literally does this actually, indirectly measuring the time taken by the load to come from point A, okay, from this point actually, right, to point B, to this point, right guys? So how does this help? Well, clearly we know the distance from point A to point B. So we know the length of point AB, right? And we know the time taken by the load from point A to B, and we know the cause of, why is it falling, and there's no other force acting on it. The only force that is acting is what? Gravity. So we know the distance, we know the time. Can we find the acceleration due to gravity? Yes, we can. Using what formula? Using S is equal to ut plus half at square. Right guys, so I'll show this calculation. But did you guys get the whole setup? I'll explain it again and you will see as well. So initially the switch A is on and the load is over here. Okay, let me erase all of this. This is your initial setup. Okay, so this is how I did it. Switch A is switched on, and I take the load and place it over there. When I switch this off, the time module starts counting. The load, it feels a pull down. It always feels a pull down, but it's held because of the electromagnet. So it has to start falling because there's nothing holding it. While acceleration due to gravity, that is actually gravitational force, is pulling it down, right? And obviously in time it will fall onto switch L, and switch L will close off, and the time module will note down the time at which switch L will note down. Switch L is switched off, and it will give us the time difference. Okay, difference in time. Time difference is measured by this circuit, this setup. Okay guys, by knowing the distance and time, we will be able to figure out the acceleration, and that's how we're going to do it. Right guys, so let me read the procedure. Set up the experiment as shown in the figure. Switch on the circuit and place the load. Measure the distance between load and the switch L. Switch off switch A and note down the time from the time module. Okay, because it just takes a fraction of a second. By the time you blink your eye, it's done. Repeat step 2 and 3 by changing the height of the load. Okay guys, so you can do this. So this would be your actual experiment. Please have a look. I hope you guys noted down the values. By default, every experiment, most of the experiment we do has certain values in them. Right? Every experiment needs for you guys to be disciplined and noted down. So we did 2 setup with 2 different heights. The first one being 86 centimeter distance between the load and the switch L, right? And the time taken in seconds is 0.42 seconds. And the second setup 146 centimeter, and the time taken is 0.55. One thing about the setup, I didn't measure the length properly. Okay, I had kept it tetromeda. It was not seetha. It was not up straight. It was a bit slanky and all of that. I didn't measure it properly. If I had measured it properly, then yes, this would have been the values. So we kind of, actually I kind of approximated them a bit. They're not exact values. It's an approximate value because I didn't measure it properly. Okay guys. Now the calculation. How will we start off with? We'll start off with S being equal to UT plus half AT square. Right, that's the formula that we're going to use. Then case 1, U is 0, T is 0.42 seconds. We can rewrite this as, let me actually do it neater. T is equal to 0.42, that is 42 by 100 seconds, and the distance S is equal to 86 centimeter, that is 86 by 100 meters, right? We can't keep it in centimeter. Now the calculation. S we know 86 by 100 is equal to half A times square 42 by 100 into 42 by 100, and we have this and this getting cancelled, then 1s are 21s are, so A is equal to 86 into 100 divided by 21 into 42. For the division and all that, well, we can use cancellation, but I'm being lazy and I'm going to do this. 21 divided by 42. 8.75. So A is approximately equal to, not 8 point, sorry, 9.75. 9.75 meter per second square. Okay, so this was your first one. Second one is, let me actually, this is something we can write it later. We still have a lot more calculation to be done. In the second setup, U is again 0. S is 146 centimeter. Okay, and the time is 0.55. 146 centimeter, which is nothing but 146 by 100 meters. Sorry, correct. That's correct. And time is equal to 0.55 seconds, which is 55 by 100 seconds. Right, and next we have 146 by 100. S is equal to ut plus half 80 square. U is 0. So again, okay, let me not confuse you guys. 0 into time plus half into acceleration. We have to figure out time is again 55 by 100 into 55 by 100. So we have 100 that can get cancelled, and 146 into 200 divided by 55 into 55 is equal to A. So let's move on to 146 into 200 divided by 55 divided by 55. And oh, this is not that great value, but the previous one was better. 9.65. So A is equal to 9.65 approximately meter per second square. So what is the average? So therefore the average acceleration due to gravity is equal to, if you add this 2 and divide by 2, it is 9.70 meter per second square is what we got. Of course, the setup and everything, yeah, I have to tune it a bit and all of that. So as of now, this is what I got. It's close to what's the actual value. So I don't mind taking this value. The acceleration due to gravity near the surface of the earth turns out to be 9.7 as per experiment. Few more setups, few more trials, and things would have been better. Right guys, but I got 9.8 close to. Okay, so we literally saw that acceleration due to gravity is 9.7 plus, close to 9.8. Actual value is 9.8. Okay, so I hope you guys enjoyed this. You also, of course, you guys can also be doing this, not an issue. It's easy to do. Few things, yes, you guys need help with. If not, it's not too hard, and it does not take too much of a money. Money factor is important for us, so it does not take too much of money. It's a smart idea, easy setup, right? You're going to learn a lot of concept from this. Okay guys, so please have a look.